of the first n terms of a series, which is usually expressed using sigma notation. The term in the series are written as the differences as simpler terms. And when you when you write out the series, lots of terms will cancel out. Today, we're going to look at how to find a formula for the sum of the first n terms of an algebraic fraction. So in a minute, I'll show you how to do sum from r is 1 to n of 1 over r times r plus 1. Now, one way of viewing this is the following, that working out the sum of a series in sigma notation feels a little bit like integration. If you're integrating an algebraic fraction, such as this one here, you would factorize the bottom in order to factorize the bottom, which is done here, split it into partial fractions, and then integrate it. In a kind of related way, to find the sum of an algebraic fraction, you split it into partial fractions and then use the method of differences. So if I want to evaluate, i.e. work out an expression in terms of m for the sum from r is 1 to n over 1 over r plus 1, the first step is to split this into partial fractions. So 1 over r times r plus 1 can be written as a over r plus b over r plus 1. By standard partial fractions methods, if you multiply through, you will get 1 is a times r plus 1 plus b times r. If you sub in r is equal to 0, you will get 1 equals a. And if you sub in r is equal to minus 1 to make r plus 1 equal to 0, you will get 1 is minus b. So therefore, b is minus 1. So what this means is the thing we're trying to sum is the same as the sum from r is 1 to n of a, which is 1 over r, plus b, which is minus 1 over r plus 1. And now we can use the method of differences. So if we see what that gives you, if you stick in r is equal to 1, you'll get 1 over 1 minus 1 over 2. Stick in r is 2, 1 over 2 minus 1 over 3. Stick in r is 3, 1 over 3 minus 1 over 4, etc., etc., etc. The final term is when r is n, so big at the bottom, 1 over n minus 1 over n plus 1. The previous term is 1 over n minus 1 over n. And the cancelling this time goes the other way, so I've got a plus a half and a minus a half, those cancel out. Plus a third and minus third cancel out. That's going to cancel, that's going to cancel. And all that leaves me with is 1 over 1 minus 1 over n plus 1, which I can just write as 1 over n times n plus 1. And we are done. That's the first example done. Second example, folks, is a more complicated one. And in the second part, there's a bit of a sum to infinity thing. I'll come back to the sum to infinity bit first of all. Can I first of all deal with part A of example 2, which is to work out the sum of the first n terms of this expression. So it's 1 over a cubic. The cubic is factorized. I'm going to split it into partial fractions, and then we'll use the method of differences, although we'll see in this case that the cancellation is a little bit more complicated. So here I'm going to write 1 over r plus 1, r plus 2 as a over r plus b over r plus 1 plus c over r plus 2. Because the bottom has those three factors. If you multiply through to get rid of the fractions, you will get that 1 is equal to a times r plus 1 times r plus 2 plus b r plus 2 plus c r plus 1. If you then sub in for example, r is 0 to make the factors of r equal to 0 disappear. You will get 1 is equal to 2a. So therefore, a is a half. If you sub in r is equal to minus 1, because that's when r plus 1 is 0. You'll get 1 is 0. For that one there, we're going to get minus b. And the third c term is equal to 0. So therefore, b is equal to minus 1. And if you sub in r is equal to minus 2, you'll get 1 is the first term is 0, second term is 0, third term is c times minus 2 times minus 1, so that's 2c. So therefore, c is equal to a half. So consequently, the thing I'm trying to sum is sigma r equals 1 to n of a, which is a half, divided by r, plus b, which is minus 1 over r plus 1, plus c, which is a half over r plus 2. Now, guys, there's various ways of dealing with this half. I think what I'm going to do is take the half through the sigma sign, take it out as a common factor. You could, however, times top and bottom of these first two fractions by 2 to remove it. If you take out half as a common factor, you'll get a half into the sum from r is 1 to n of 1 over r minus, I need to put a 2 on the top to cancel out the half that was taken out as a factor, r plus 1 plus 1 over r plus 2. And I can now try to do this using the method of differences. So what is this going to be? The first term, so it's a half times a whole load of stuff. The first term is going to be what you get when you stick in r is 1. You will get 1 over 1 minus 2 over 2 plus 1 over 3. I would not simplify any of these fractions before writing them down because it might make it harder to spot the cancellation that will occur. Add. The second term is when r is 2. You're going to get 1 over 2 minus 2 over 3 plus 1 over 4. The next term is when r is equal to 3. You'll get 1 over 3 minus 2 over 4 plus 1 over 5. Now, the cancellation here is more difficult to spot, folks, but the cancellation is I've got a plus a third and a minus 2/3 and a plus a third, and they're going to cancel out. In addition, a quarter minus 2 quarters plus a quarter is going to cancel out. That's the cancelling. If you go down to the bottom, let's get back to red. To do this, the very, very last term is when r is n. So it's 1 over n minus 2 over n plus 1 plus 1 over n plus 2. The previous term is 1 over n minus 1 minus 2 over n plus 1 over n plus 1. And all of this is going to cancel out as well. And all of that's got to be times by a half. So what you end up with is the following. This is the same as a half into the only terms that survive, the only terms which don't cancel out are this triangle of terms at the top and this triangle of terms at the bottom. So you get 1 over 1 minus 2 over 2 plus a half from the top. And then at the bottom, you will get plus 1 over n plus 2 minus 2 over n plus 1 plus 1 over n plus 2. I'm just going to simplify that a little bit, folks. So that's the same as a half into, I've got 1 minus 1, that will just cancel out. I've got a half, I've got 1 over n plus 2 plus another 1, which is 2 over n plus 2 minus 2 over n plus 1. That is my expression for the sum of the first n terms. Now, you may, in exam questions, have a show that question. You may be required to combine this together to make it a single fraction. You would do this by finding a common denominator. But there's the sum of the first n terms. That's part A done. Now, part B wants you to find the sum to infinity. Didn't want that to happen. Wants you to find the sum to infinity of this sequence, i.e. the sum from R is 1 to infinity of this sequence. Can I just clear the board a little bit to get some space, and then I'll go through how to do that. So what I have shown is the following. I know that the sum from R is 1 to n is given by a half into, previously, there was a half into a half plus 2 over n plus 2 minus 2 over n plus 1. That's my answer to part A. Okay, so here's my answer now to part B. So the sum to infinity in A-level mathematics, the only sequences that you're required to find the sum to infinity for are convergent geometric sequences. It's A over 1 minus R. In further maths, we can find the sum to infinity just by seeing what happens as n gets large. So the proper way of doing B is to say this is equal to the limit as n tends to infinity. That means as n gets larger and larger and larger of the sum of the first n terms. And the sum of the first n terms is given by a half into a half plus 2 over n plus 2 minus 2 over n plus 1. Now, the idea is this. As n tends to infinity, n gets larger and larger and larger. N plus 2 and n plus 1 will get larger and larger and larger. So 2 over them would get smaller and smaller and smaller. So these two terms here are going to approach 0. So therefore, the answer is a half into a half plus 0 plus 0. The sum to infinity of this sequence is given by a quarter. Okay, folks. So students, what I'm going to ask you to do is pause the video. There's a you try question on the next page. Have a go at that, and then I'll go through the answer for that in a second. Okay, folks, so the first thing here, given that sum from R is 1 to n, 1 over R plus 1 is 1 minus 1 over n plus 1. That's what we proved earlier. Evaluate the sum to infinity and find n if the sum from R is n plus 1 to infinity is 1/655. So here's the first bit. What I need to do is the limit as n tends to infinity of this expression. So as n approaches infinity, n plus 1 approaches infinity, 1 over n plus 1 approaches 0. Therefore, the sum to infinity is equal to 1. To do the second part, the sum from R is n plus 1 to infinity is the difference between the sum from R is 1 to infinity and the sum from R is 1 to n, because we are adding together all of the terms starting at n plus 1. Now we know that the sum to infinity is 1. The sum of the first n terms is 1 minus 1 over n plus 1. So that is that plus 1/65. If you rearrange that, you get 1 over n plus 1 is 1/65. N plus 1 is 65, so n is 64. Now, students, example 3, I'm just going to go through one more question, which is similar to what we've done previously, but a little bit different. The thing that makes this different is this factor of minus 1 to the r, which is in front of the expression. Now, can I just draw your attention to minus 1 to the r does the following. When r is 1, minus 1 to the 1 is equal to minus 1. When r is 2, minus 1 squared is plus 1. When r is 3, minus 1 cubed is minus 1. When r is 4, it's plus 1. So it multiplies by an alternating factor of plus or minus 1. It switches the sign of the term. Okay, folks? I'll come back to that in a second. To do this, the first thing I'm going to do is to split this into partial fractions, and then we'll try using the method of differences, and we'll bear in mind this bit here. So I know that 2r plus 3 over r plus 1 times r plus 2 should be able to be written as a over r plus 1 plus b over r plus 2. If you multiply through, you get 2r plus 3 is a r plus 2 plus b r plus 1. If you stick in r is equal to minus 2, you will get minus 1 is equal to minus b. So therefore b is equal to 1. If you stick in r is minus 1, you will get 1 is equal to a. So consequently, what I'm going to try to find the sum of is the sum. Now, please note in this case, it starts at r is 0 and the last term is not n, it is 2n. Still gives method differences of that. Well, that's the same as minus 1 to the r multiplied by my partial fraction form, which is 1 over r plus 1 add 1 over r plus 2. So students, let's see what this is going to give us. So the first term means sub in r is 0 in this case. Now minus 1 to the 0 is just 1. So when you stick in r is 0, you're just going to get 1 over 1 plus 1 over 2. That's what you get when r is 0. Then sub in r is equal to 1. So minus 1 to the 1 is minus 1. So both of the terms are now going to become negative. So it's minus 1 over 2 minus 1 over 3. Then when r is equal to 2, minus 1 squared is 1. So it's positive. So it's going to be plus 1 over 3 plus 1 over 4. Can we see how the cancelling is going to work here? I think we can a little bit, and then keep on going to the end. Now, in this case, please be careful. The last term is going to be when r is 2n. Now, 2n is an even number. So minus 1 to the 2n is plus 1. So we're going to get plus 1 over 2n plus 1 plus 1 over 2n plus 2. That's the very final term that we're going to get. The previous terms are when r is 2n minus 1, which is odd. So we're going to get minus 1 over, it will be 2n minus 1 over 2n plus 1. That cancels out, that cancels out, that cancels out, that cancels out, that cancels out. So what I'm end up with is just 1 over 1, which is 1 plus 1 over 2n plus 2, because everything else cancels out. Now to write this as a single fraction, 1 is 1 over 1 times top and bottom by 2n plus 2. You get 2n plus 2 plus 1 over 2n plus 2. So it is therefore 2n plus 3 over 2n plus 2 as required. Okay, students, that's method of differences done. You should now be in a position where you can do exercise 2, ladies and gentlemen.